there are people out doing practical things in the world, making forecasts. We've had this. We trained a lot of forecasters during the war. There are the real weather people that are out fighting it, trying to predict what the weather will be tomorrow, next week, or 10 days from now. These are the people down in the trenches doing, but this is dirty business. Messy, dirty, you're always wrong to some extent. You don't, I want to be a scientist, a pure scientist. You don't want to do this. You want to live in a clean virtual world. And what happened was, when the computer came along, everyone thought this is the wave of the future. I'm going to model, I'm going to develop. This grubby people out handling data, they're old-fashioned. We're going to do, and the computer thing has grown like this tremendously, and they all live in a virtual world. They don't compare with nature. They all live in a virtual world, and that's what's happened. They've all started, and they said, well, look, if the CO2 goes, my model says in 50 or 100 years, we're going to have all this warming. But the one thing they don't do, and it's a crime, they don't predict next year's weather. They don't say whether, well, okay, how about next winter, next summer? Is it going to be colder or normal? They say, well, we can't predict the individual day weather. That I accept. But you could say, next year, the summer of 07, 08, is it going to be colder than normal or warmer than normal? They don't make that forecast, but they make it 100 years from now. And we tolerate that. They're living in their own virtual world. They're painting themselves into an ever smaller corner because they're more and more. When I got started in meteorology, when NCAR was formed in the middle 60s, and so there were all kind of problems you worked on. There were all kind of weather problems, this and that. But more and more, they've gotten to the public, and they've said we need big amounts of money. And with the wind down of the Cold War, see, the government since the Second World War, since Sputnik, we've been worried about the Soviets. They had their good science, they invested a lot, and we had to keep up with it. So we poured a lot of money into science research. Now, since the Cold War wound down, we need, what is the justification to put all this money into these government labs and things? You've got to get a common enemy. What common enemy? Global warming. We can all unite to fight global warming. Give me money. I want, and they live in their virtual world. And they're good. They're well paid. They go to meetings. They scratch each other's backs. They not only they review each other's papers, and they get published and stuff. That's unfortunately that's the way it goes. Now there's a number one question. When you're a scientist, what's the number one thing you need? Money. A salary. Right. You need a salary. Now, after I've secured my salary, my kids can eat, my wife can buy a new dress every year, then I'm worried about doing research. And that's essentially, so we've let this go out. People like Gore, you see, that I'm sure the young people are very environmentally oriented. And I think Gore, 20 years ago or so, made this thing cheap. This environmental movement's going. Granted, we have environmental problems. We have all these things. I'm going to get in front of this and lead the way, and it will carry me to high political office. And I think they built these, well, anyways. I want to tell you how bad the global models are. They are terrible. They can't predict next season, next year's weather, but they tell us what it's going to be 100 years from now. And the reason is, what the models do, there are ways to predict the weather. I'll show you another slide here. We do seasonal weather forecasting at CSU, and it's an empirical way. What we do is, we look in the past. Like I've been for 24 years involved with these seasonal forecasts. We go 3, 6, 9 months in the past. And we say, gee, 3, 6, 9 before active hurricane seasons. We often have the atmosphere and ocean functioning a certain way that's different than it is 3, 6, 9 months before inactive years. And we use that. It's just an empirical method. So we go back in the past. We have this method here where we go measure things in the past. And then we go forward with time and say, well, if the atmosphere in the future behaves as it has in the past, then we should have an active or not so active hurricane season. Now the numerical models that I want to compliment, they are wonderful at 5 to 10 days. I've been around when they first started in 1955. First numerical models got started, they do marvelous. The upper air patterns. The prediction that it's going to rain tomorrow in Denver, it hasn't improved much in 50 years. But the upper air patterns, whether the next 5 days are going to be colder than normal, warmer than normal, or generally wetter or drier, that has improved a lot. So what do they do? With all the new satellite, all the new measurement techniques, you measure the flow fields around the globe and you extrapolate or advect these forward in time. And that works pretty well. Going out 5 days, 8 days or so. You measure things. Well, how these are different is the numerical models don't care about the past. They don't measure past weather. They measure things now. T equals 0. Then they integrate these things forward, and they do pretty well with, you can measure the momentum fields and extrapolate those forward. But you can only go so far with that, because the atmosphere runs itself down in an 8 or 10 day period. The friction runs the winds down, you got to generate new winds to balance it, and then you get into this area where things are so complex, where beyond about 10, 12 days or so, you get into the energy things. As long as momentum dominates and you don't have to deal with energy, radiation differences, condensation, warming, evaporation, cooling, air-sea interaction, all these complex energy things, and it's a can of worms. It's an absolute can of worms. Here's the climate system. Now you tell me you can write code for all this complex thing and integrate it hundreds of thousands of time steps in the future and get anything out? You can't. It's mush. You're operating in the virtual, the world of chaos. These are butterflies and things jumping around. It's no damn good. And they know it's no damn good because they don't make forecasts. They won't make a forecast for next year or 2 years or 3 years down. But they say, believe me, in 100 years. They said, well, how about telling me next winter or next summer or so? Well, no, we don't do that. We don't do that. And the reason they don't do that because they know they don't have any skill and they would be verified. The last thing these modelers want to do is be verified, because they know they would lose credibility. Richard Lindzen, MIT, we agree very much. He believes the margin of error in these global models is a factor of 10 or more larger than what they're looking for. I agree completely with that. They're no damn good. Doesn't matter what. That there's about 30 or 35 global models around the globe, all spitting out, all saying much the same thing. They're just no damn good. If they were any good, they should predict next winter or next summer. Tell me something more useful. Not only are they no damn good, they're warning us incorrectly, You know, a doctor, the first thing the code is do no harm. Well, these global modelers are doing harm because they're warning us, alarming us when they shouldn't be. And they're taking all our money. And guys like me who down in the trenches trying to get money, no, Gray's old-fashioned, he doesn't model, this isn't the real world. Well, we're making forecasts and verifying our forecasts on a regular basis. We're down in the trenches. So the problem has been the whole thing has gone crazy.